Hi, welcome to my video on proofs with CPCTC. Proofs with CPCTC. CPCTC stands for Congruent Parts of Congruent Triangles Congruent. CPCTC, the first letters in the statement. When triangles are proven congruent, their other parts are congruent. Let's do some examples. A, we have a triangle. We're given that AB equals AC. AB equals AC. We're given that angle 1 is equal to angle 2. And we have to prove that 3 is equal to 4. So how do we prove 3 is equal to 4? Let's see if we can get some congruent triangles. So, try to do the proof before we start. Write it up. If 1 equals 2, that means that OB is equal to OC. Mark it with 2 strokes because they're 1 stroke there. These are 2 strokes. Indicate they're different measures. And we have AB equals AC. We have OB equals OC. We also have AO equals AO because it's a common side. So these two triangles, AOB and AOC, are congruent by SSS, 3 sides equal. And that means that if the triangles are congruent, that means 3 is equal to 4. So that's how I had the proof done. Let's now write it up officially. So we have AB is equal to AC. We can put angle 1 equals angle 2. I'm going to sometimes ask your teacher if you can put all the givens in the first statement, or do you have to keep them separate? If angle 1 is equal to angle 2, OB is equal to OC, and that's the converse of the ITT. If 2 angles of a triangle are equal, then the sides opposite those angles are equal. So we have 2 sides. We need a third side. So AO equals AO, and common. That's a common side. Common CO. Okay, common side in the triangle. Now we have the triangles congruent. AOB is congruent to triangle AOC. And the reason is SSS congruency. And because we have the triangles congruent, then angle 3 is equal to angle 4. And we say CPCTC. Check with your teacher if they use this statement, or some people go CPCTE. Congruent parts of congruent triangles congruent. B, we have 2 triangles that are congruent. So PMQ is congruent to RMT given. We want to prove the lines parallel. So how do we get the lines parallel? Well, normally we need a pair of equal angles. So I have to get angle Q equals angle T, or angle P equals angle R. Because these angles are equal to alternate interior angles, lines are going to be parallel. So we have the triangles congruent given to us. So that's the given. And because it's given, I can say that angle Q equals angle T, and it's CPCTC, congruent parts of congruent triangles congruent. And because this angle Q equals this angle T, that means that PQ is parallel to TR. Because we have the angles, so that's the converse of the PLT. And these angles are alternate interior. Alternate interior angles equal. We did that in the earlier videos on converses and on parallel lines. Check it out. So, 2 proofs using CPCTC. And let's do some more. The more we do, if you want, pause your video and see if you can do these proofs beforehand. Here we go. We're given that angle 1 equals angle 4 in this triangle. So there's angle 1 equals angle 4. We're given that XM is perpendicular to VY, so perpendicular. These are right angles here, which are going to be equal. And we want to prove that VM equals YM. So that means we need the triangles congruent. If we can get the triangles congruent, then we have these parts, 2 segments. These 2 segments are equal because of congruent parts of congruent triangles. Congruent. Notice I'm not just differentiating between congruency and equal. Equal is congruent, congruent is equal. So check with your teacher. So we have, I got to get the 2 triangles congruent so I can get these 2 angles are equal. I can get these angles equal by SAT, supplements of congruent angles are congruent. This side is, if these angles, these 2, this is perpendicular, so I can have right angles equal. I can also have a reflexive. I can also have XM equals XM. So let's see. I got angle 1 equals angle 4. That's a given. Number 2, I have angle 4, angle 3 are linear pair, and angle 2 and angle 1 are linear pairs. And that's the definition of a linear pair. Linear pairs are 2 adjacent angles that form a straight angle. Definition of linear pairs. This is a linear pair. Why? 2 adjacent angles that form a straight angle. Because they're linear pairs, we have angle 4 is supplementary to angle 3. Angle 2 is supplementary to angle 1. Because they're linear pairs, we have a straight angle that makes them supplementary. And that means, since 1 equals 4, that means angle 3 is equal to angle 2 by what we call supplement angle theorem, SAT. Supplement angle theorem. Supplements of congruent angles are congruent. We did that in earlier proofs on the videos. Now we got angle 3 is equal to angle 4. We need, we can have, let's go with, take these 2 angles here. Let's go with 5 and 6. I can say angle 6 is equal to angle 5 because perpendicular lines form congruent adjacent angles. Perpendicular lines or segments form congruent adjacent angles. We did that in an earlier proof. What happens is that because they're perpendicular, these are 2 right angles. And because they're right angles, they're 90 degrees and they're equal. There's another way you could do it. So we have these angles equal. We have 3 is equal to 2. We have 5 is equal to 6. And we can either say converse to the ITT, 3 is equal to 2, so we can go with XV equals XY, or we can go with XM. XV equals XY, converse to the IT, or XM, let's go with XM equals XM, common side. And now we have enough to have the triangles congruent. The triangle XMV is congruent to triangle, make that a triangle XMV. y, make that an x, and we have 3 is equal to 2, 5 is equal to 6, so that's an AAS, angle, side. If I did go with XV equal to XY, converse of ITT, I would have had again, I still would have had an AAS. And because we have that, triangle is congruent, that means we have VM equals YM CPCTC. Okay, let's try another proof. We have a diagram here. We have 1 equals 2. So we have angle 1 equals angle 2 given. Remember, I try to do the proof beforehand, before I write it up. See if it makes sense. Put it together. FB equals HB because of the given. Now, what do we have? How are we going to get the triangles? I got to get the triangles congruent. I can see that BC equals BC, common side. So that's a side equal, that's an S and an S. I need this angle in between. Oh, 1 is equal to 3 by VOAT. If lines intersect, the vertically opposite angles are equal. So 1 equals 2 and 1 equals 3. That means 2 is equal to 3. That means I have an SAS congruency. That makes, I got to prove that BC bisects FCH. So FCH is this angle. I got to prove a bisector, so I need to get these two angles equal. So I get the triangles congruent, and I get these two angles equal. So here we go. Number 1, angle 1 equals angle 2. Given. Angle 1 equals angle 3. VOAT. Again, I do that, but just VAT. That means that angle 2 equals angle 3. Transitive property of equality. And number 4, we have FB equals HB given. We have BC equals BC. Again, a common side. BC is in both triangles. So now I have SAS. So the triangles are congruent. So FBC is congruent to HBC by side, angle, side congruency. Side, angle, side. Side, angle, side. And that makes 5 equal to 6. CPCTC. Congruent parts of congruent triangles congruent. And number 8, because these are equal, so BC bisects angle FCH. Definition of an angle bisector. And we have the proof done. Again, always look at what you're given, mark your diagram, and then look at what you got to prove, and then see how you're going to follow it through. I do the proof beforehand in my head, right? And then I write it up after. It makes it much easier and plainer to do. Number 3, don't forget you can pause your video and do the proof and see if you're going to be okay. But proofs can have different steps. That's the only thing about proofs. The sequencing might not be the same order as what I'm going to do. But you'll see how the proof is working. So we have this diagram. 1 is equal to 2 given. We got AB bisects EC. AB bisects EC, so it makes this BE equals BC. We got PE is perpendicular to EC. We got AC is perpendicular to EC. And we got to prove that angle 3 is equal to angle 4. Angle 3 is equal to angle 4. Again, we could, in previous proofs, we worked on parallel lines here. 1 equals 3 and 2 equals 4. And because 1 equals 2, 3 is equal to 4, without having congruent triangles. But I don't have parallel lines, so I have to work with 3 and 4 are in P, E, B, A, C, B. So it looks like I'm going to have to get these two triangles, A, C, B, P, E, B, congruent. So if 1 equals 2, that means that PB equals AB, converse of the ITT. So notice I have these two sides equal. I have these two sides equal. And I have perpendicular lines. So that looks like these angles are equal. But if I say these angles are equal, I got an ASS, and I can't say that in a proof. So because they're perpendicular, I have to make these triangles right triangles and then use the hypotenuse leg. Okay, I have the proof. So angle 1 equals angle 2. Given. That makes PB equal to AB, converse of the ITT. Two angles of a triangle are equal, the sides opposite the angles are equal. So we have AB bisects EC right there, given. And because it bisects the segment, that means BE is equal to BC. Definition of a segment bisector. Okay, now I have to go with the perpendiculars because I have a side and a side, but I can't say the angles are equal because it's been ASS, so I have to go PE perpendicular to EC. I'm putting both of these givens in the same step. They go together. That's the given. That means that angle, the perpendiculars, so that means that angle E and angle C are right angles. Perpendicular lines, definition of perpendicular lines or segments. And because they're right angles, that means that triangle PEB and triangle ACB are right triangles. And that's the definition of right triangles. There's an S there for triangles. That's an S for triangles. I got right angles, so I got right triangles. Now, because I have right triangles, then I have that the triangles PEB is congruent to triangle ACB, and it's what we call the HL, hypotenuse leg. This is the hypotenuse because it's opposite the right angle, and this is the leg. And as a result, because the triangles are congruent, angle 3 is equal to angle 4, CPCTC. Hope that proof makes sense to you. And I'm using all the videos that I did in the previous videos on congruent triangles, using in these proofs. And that's the beauty. They keep repeating over and over and over. Number 4. You got to do the proof. The MA is parallel to TH MH is parallel to TA. This is one stroke, indicating these two are parallel. Two strokes, these are parallel. And I have to get that MH equals TA. I need to prove the triangle is congruent. Notice this is a common side. So I need angle, parallel lines gives me equal angles. So I'm going to name the angles 1, 2, 3, and 4 instead of using 3 letters. So because MA is parallel to TH, 1 is equal to 3. Because HM is parallel to TA, that means angle 2 is equal to angle 4. Notice that's PLT, alternate interior angles equal. So now I have this triangle here, MAT, is an ASA congruency. And that makes the two sides equal CPCTC. So here we go. I have it laid out. So MA is parallel to TH. Again, I can put the two givens. No, I'm going to do one given at a time. So of MA, that means angle 1 equals angle 2. The reason I'm doing separate to show you the different angles. Angle 1 equals angle 3, alternate interior. And that's to parallelize the PLT, alternate interior angles equal. And number 3 is that MH, TA, parallel, given. And that means angle 2 is equal to angle 4. And that's the same reason as number 4 here. That's a PLT, alternate interior angles equal. Again, I could have put the two of these in the given, and I could put the two of these in the PLT. I could have had only 2 steps instead of 4, but I kept them separate to show you your alternate interior angles with different parallel lines. And I have, notice that MT is equal to TM. The M goes with the T, and the M in this triangle goes with the T in this one, and the M in this triangle goes with the T in this one. So it's an MT-TM, and that's a common side in both triangles. Side is commons, so they're equal. Now we have the triangles, and we have MTA congruent to TMH, and that's an angle side angle congruency. Notice angle side angle. In this triangle MHT, angle side angle. And as a result, we have M, or I could say TA is equal to MH, just different order. I put the triangles down like that, so it don't make any difference if I got TA equals MH. With one, I have MH here, but because I have the TMH, I put the MH on this side, the TA on that side. Same thing. Congruent parts of congruent triangles congruent. Okay, and we have one more proof to do. And let's see. Again, let's just look at what we got to do and figure out the proof first and then write up after. PR bisects QT. So PR bisects QT. Because they bisect, I have PS equals RS, and I have QS equals TS. Because they bisect, I have angle 1 equals angle 2, VOAT, vertically opposite angles equal. So that makes these triangles congruent. So how am I going to get the parallel lines? I got angle R is equal to angle H given. So I want to get that PR is parallel to HV. If PR is parallel to HV, I need angles. So let's pretend if they were parallel, then I would have this angle P equals angle H, or if the angle 1 equals angle V. So how am I going to get the parallel lines? I need a pair of angles equal. But now notice I got R and H. So if I got R and H, they got to be connected somehow. So how am I going to connect them? Well, I have PR I need to get. I have P, so I have to go right here with P. So the triangles are congruent, so that means R is going to equal angle P because of the congruent triangles. And we got R is equal to H, so therefore P is going to equal H by transitive, and I got the parallel lines. So here we go. I have it. PR and QT bisect each other. Given PS equals RS and QS equals TS. Definition of segment bisector. Angle 1 equals angle 2. VOAT or VAT, vertically opposite angles theorem. Two lines intersect, the vertically opposite angles are equal. That means I now have the triangles R, S, Q, congruent to P, S, T, PST, RS, PS, that's right, I'm just making sure, and that's an SAS congruency. I have a side, an angle, and a side, angle, and side. And as a result of the triangles congruent, I have angle R equals angle P by CPCTC. Number 6, I have angle R equals angle H given. So if R equals P and R equals H, that means angle P is equal to angle H by transitive property of equality. Again, check with your teacher. If you say transitive property, do you have to put of equality? And because these angles are equal, that makes that PR is parallel to HV, and that's converse of the PLT. And what type of angles are they? Alternate interior angles equal. Notice Z. When you form a Z, they're alternate interior, transversal, and they're both interior angles that are alternate across the transversal. Notice I had R equals H given. So because I had R equals H, that means there must be another angle that's going to connect these up. So P is the angle that goes with H. So that's why I had to do the congruent triangles first. So always look around. Figure it out. Those proofs are excellent to do. Keep your brain sharp. If you like my video on the proof CPCTC, click the like button, subscribe button, notification bell. Visit my website www.mathfullyexplained.com to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Bye-bye.